Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. In previous session we have learned that what is a firing wheel control circuit. Here we have a place on our Vero board to wire up the circuit of Triac and MOC3022. Here we can see we have a circuit of power Triac, that is BTA06-600, and the circuit of MOC3022 to trigger the Triac. We'll complete this circuit on our Vero board and we'll write a program to test the circuit. Then we'll develop the complete firing wheel control circuit. Here we will place the power interface connector of our circuit. Here we have inserted the power interface connector in our Vero board. We'll apply 220 volt on first two pins of this connector and we'll connect the load from these two last pins of this connector. Now we'll join pin number 2 and pin number 3 of this power interface connector. Here we have connected pin number 2 and pin number 3 of this power interface connector. Now we'll complete our circuit. Here we have the Triac, that is BTA06-600. The rightmost pin is gate, the middle pin is A2 and the leftmost pin is A1. We'll apply 220 volts at center input of this Triac, which is A2, and we'll get the output from left pin of this Triac, which is A1, and we'll connect the right pin, which is gate, to the trigger circuit of MOC3022. Here we have inserted the Triac in Vero board. The rightmost pin is gate, middle pin is A2 and the left pin is A1. Now we'll complete the circuit. Here we have soldered M2 and M1 pins of this Triac. Now we'll complete the gate circuit. Now we'll insert a 6-pin base in Vero board for MOC3022. Pin number 1 of this connector will directly go to pin number 6 of MOC3022. Now we'll connect pin number 4 of MOC3022 with the gate of the Triac using 100 ohm resistor. Here we have a 100 ohm resistor. Here we have inserted the 100 ohm resistor in Vero board. Now we'll connect pin number 1 of MOC3022 with 5 volt using 180 ohm resistor, and we'll connect pin number 2 with the anode of the LED. This LED is used to indicate the Triac is on or off. Here we have a 180 ohm resistor, and here we can check that this 4.7K resistor is connected with 5 volt. Okay, we'll apply the 5 volt to the MOC3022 from this point. Here we have inserted 180 ohm resistor in Vero board. Now we'll check the continuity of 5 volt with this resistor. Okay, 5 volts are connected with this resistor, and the second end of this resistor is connected with pin number 1 of MOC3022. Now we'll check the anode and cathode of this LED. Okay, the right pin is anode and left pin is cathode. Now we'll connect anode of this LED with pin number 2 of MOC3022. Here we have inserted the LED in Vero board. Here we have completed the circuit of Triac and MOC3022. Now we'll connect the cathode of this LED with microcontroller. And here we can check FAC signal is connected with microcontroller at pin number 9, which is RE1 port of this microcontroller. Now we'll connect the cathode of this LED with pin number 9 of the microcontroller. For this we'll use the wrapping wire. Here we have completed the circuit of Triac and MOC3022, and we have connected the cathode of the LED with pin number 9 of the microcontroller. Now we'll perform a continuity test of our circuit. The first pin of this power connector is connected with the center pin of this Triac. Okay, center pin of the Triac is connected with pin number 1 of the power connector. Pin number 2 and 3 of the power connector are connected together. And these two connectors are not connected with pin number 1. And pin number 4 of this power connector is connected with terminal A1 of this Triac. Okay, terminal A1 of this Triac is connected with pin number 4 of the power connector. Pin number 6 of MOC3022 is connected with pin number 1 of power connector. Pin number 4 of MOC3022 is connected with 100 ohm resistor. And the second end of this resistor is connected with the gate of the Triac. Okay, the circuit is completed. Now we'll check the continuity of pin number 1 of MOC3022. And this resistor is connected with 5 volt. Okay, 5 volts are connected with 180 ohm resistor. Anode of this LED is connected with pin number 2 of MOC3022. Okay, and the cathode of this LED is connected with pin number 9 of the microcontroller. Okay, the circuit of LED is completed. Now we'll insert MOC3022 in the base and we'll write a program to switch on and switch off a lamp of 200 watt. Here we have MOC3022 optically isolated Triac. Here we have inserted MOC3022 in the base. And now we'll connect 220 volt power supply to pin number 1 and pin number 2 of this connector. And we'll connect a lamp of 200 watt at pin number 3 and pin number 4 of this power connector. Here we have connected 220 volt power supply with pin number 1 and pin number 2 of this power connector. Here we have connected a 200 watt lamp with Triac circuit. Now we'll write a program to switch on and switch off this lamp with the help of Triac circuit. We'll use switch 1 to switch on the lamp and switch 2 to switch off the lamp. And we know that switch 1 is connected with port RD4 and switch 2 is connected with port RD5. And the control signal for MOC3022 is connected with pin number 9 of this microcontroller, which is port RE1 of this microcontroller. First we'll go to the project, new project, a standard project. And the project name is fire angle control, that is FAC underscore control. And the project folder will be in Micro C project. We'll create a new project, FAC projects. Okay. Device name is PIC16F877A and the device clock frequency is 10 MHz. Okay, next, finish. And here we have the main project starting from wide main. Now we'll add some comments and assignments in our program. Here we have assigned the name to our project, that is firing angle control project. Now we'll write some bits assignments. we'll write define SW lamp underscore on port RD4 and we'll write define switch lamp off port RD5 Now we'll assign the bit for fire angle control signal. FAC signal port RE1 Here we have completed our assignments for this program. Now I'll write the main program, and here we have our main program. In main program we'll write a while loop, that is while 1, and we'll write the while loop between these two braces. Before while loop in main program, we'll assign the directions to the port, that is T.F4 equals to 1. It means port RD4 is configured as input port. We'll assign comment here. Port RD4 is configured as input port. Now port RD5 equals to 1. It means port RD5 is configured as input port. Now we'll assign the direction to port RE1. Equals to 0. It means port RE1 is configured as output port. And now we'll write a subroutine in while loop. Here we will write lamp control and we'll write the lamp control routine before main program. And here we will write the lamp control routine, that is void lamp control, and we'll write the lamp control routine between these two braces. Here we will check if switch lamp on, Control C, and we'll paste it here, Control V, equals 0. If the switch lamp on signal will be low, then our program will come into this if statement, and here we will write FAC signal, Control C, and we'll paste it here, Control V, equals to 0. As we know that FAC signal is active low. Now we'll check for the second switch, and we'll write if, we'll copy the assignment for second switch, Control C, and we'll paste it here, Control V, equals 0. If the switch lamp off input will be low, then our program will come into this if statement, and here we will write FAC signal, Control C, Control V, equals to 1. If FAC signal will be 0, then MOC3022 optocoupler will be on, and if FAC signal will be 1, then MOC3022 optocoupler will be off. Here we have completed our program. First we'll test our Triac circuit, then we'll write our program for fire angle control. Here in this program we will just switch on and switch off 200 watt lamp. Here we can check our program is compiled successfully and hex file is generated. Now I'll connect Picket3 programmer with prototype. Okay, go to the file, import hex, and in FAC projects we have a hex file, that is FAC control. Okay, right. Now we'll switch on our prototype. Our program is not working. Let's see what is the reason of this problem. As we can see, FAC control signal is connected with pin number 9 of this microcontroller, which is port RE1, and this pin is also analog input of this microcontroller. So we have to configure this pin as digital output in our program, and here we can check from the datasheet of PIC16F877A microcontroller that we have to configure these bits from ADCON1. Here we can check we have 4 bits, that is PCFG0 to PCFG3. And if we'll use this configuration, if we'll assign the value that is 2 to these configuration bits, then we'll have 5 analog inputs out of 8, and we'll have 3 bits as digital input output. So here we can see analog 5, analog 6, analog 7 pins will be digital input output. So we'll assign the value 2 to ADCON1 register. Now here in a program we'll assign the value 2 to ADCON1 register. So we'll write ADCON1 equals to 2. Now here we have configured port E1 as digital pin, and here we have configured port RE1 as digital output, and here we'll also initialize port RE1 as 1. So we'll write port EF1 equals to 1, and initially the lamp will be off. Now we'll compile our program once again and we'll observe the result on our prototype. Okay, right. Now we'll power up the prototype once again. Now we'll press switch 1. Okay, the lamp is on. Now I'll press switch 2. The lamp is off. It means Triac circuit is working properly. Now we'll develop the zero crossing circuit here, and we'll write the program for fire angle control.